3.2 is talking about logarithmic functions as well as dealing with both logarithmic and exponential. Notice these things are synonymous. They mean the same thing. Y equals log base a to the x. This a right here is your base. Just like in exponential form, we had a base of a because it was being raised to the y. So we have a base and we have an exponent. Well, yeah, I have an exponent in here. And I have an exponent as well. It equals the exponent on this side. The easiest things to remember are the bases, where they go. You should always, always, always at least get the bases right. Okay, and the exponent is what is equal to in log form, and the exponent is just the exponent in exponential form. What we have left, we just call this the number. Number. Equals the number, you take the log of a number. Okay, the way that I see this in my crazy brain is if I have log base 3 of x equals y or something, I see that 3 is the lowest thing written. So 3 to the y, go over the opposite sign, then I have equals x. So then 3 to the y equals x, and there it is rewritten as exponential. Okay, that's the way that I see it in my crazy mind. However you see it is cool. Whatever way you want to come up with, not a big deal. Just make sure you come up with the same sort of method. You have the base, so you have the base. You have the exponent equals the exponent over here. And the number is just what's left over. Goes on the other side of the equal sign in exponential form and is the number that you're taking the log of in logarithmic form. Got to know both ways. I'm going to look at two different examples of rewriting these as the opposite way. So in this first way, in this one right here, I have an exponential form already, and I need to rewrite it as a logarithm. Well, I have my base, I have an exponent, which I know is what it equals to, and I have my number, then. So if I take the log of my base, so 3, equals my exponent, and then I put my number inside the log. There it is. That's simple as it gets. Okay. On this other one, I need to rewrite it as exponential. I have 2 as my lowest number, raise it to the opposite, so 2 to the 4th equals whatever is left, equals 16, the number inside. Bueno, that's all you got to do on stuff like that. You don't even have to simplify 2 to the 4th. If you do, cool, awesome. But just know in multiple choice and in, well, yeah, just mainly in multiple choice, they may list it as 2 to the 4th equals 16 as the rewritten form. This next part is just kind of some basic facts about log. Okay, you may see something like this, which means your natural log of x. That's just what it means. So if you see something that has ln x and there's no base, the understood base is e. With log of x, we're in a base 10 system, 1 through 10, 11 through 20, 21 through 30, right? We have a base 10 system. So if you don't see a base, the base is 10. If you have log of 1 or natural log of 1, so you have 10 to the 0, well, 10 to the 0 power is 1, so log of 1 equals 0. Natural log of 1 also equals 0. And anytime you take a log of 1, it will equal 0. If you have the same base as the same number inside, it's just equal to your exponent. Likewise, if you have the same, if your base is the same as the base in your log, when it's being raised to your log, it's just equal to the number inside. These are just kind of some basic truths about logs and natural logs. It'll work for both of them just the same. Your parent function of your log graph, as long as a is bigger than 1, as long as you have a base bigger than 1, looks exactly like this. It will cross at the point 1, 0, and it will go up and to the right. You also have a vertical asymptote at y equals 0. Okay, so you have a vertical asymptote, y equals 0. Okay, the way that I think of this is if you're running, right, you got a running man, he's going super fast, he's got wind blowing behind him, and he has to jump over a log. He's going to go head first and jump over the log, right? Kind of similar. So it's kind of like there's a big log down here, and he has to jump over the log. Also, notice this kind of looks like your graph y equals a to the x. These are actually inverses of each other. So if they reflect over the line y equals x, this one crosses at 1, and it goes up and to the right and down and to the left, as long as a is bigger than 1 in both cases. Same the same. Inverse. This one is your y equals a to the x. The red is your log graph. Make sure you know it. If you don't know it, you're going to have some issues. Because again, 3.2 has a lot of non-calculator stuff with it as well. Say we wanted to graph a transformation of this. Again, transformations, don't forget, you need to be thinking about Mrs. Backwards. Okay, again, I'm Mrs. Backwards, so said it in the last video. He makes me enchilada casserole, he feeds me dinner at night, he even feeds it from my face, and he draws the airplane in, and he says, ready for the airplane, and then I eat a big old scoop of chicken enchilada casserole. It's delicious! Okay, so any stretching or shrinking, well, I have 2 to the x again. 2 is with the x, so that means I'm going to multiply my x's by the opposite, so x is by 1/2. Any reflections? Well, I have this negative on the outside of my log. Since it's not with the x, that means it's kind of with the y. If I take a point on my y and I flip it over the y, make it negative y, then it actually went over the x-axis. And my move, notice how there are not parentheses there. Since there are not parentheses, this -3 is outside. It's with the y. It's not with the x since it is not in parentheses. So I'm actually going to move in the y direction down 3. Okay, so when I graph my equation, erase those. I know my parent function is at 1. It goes over the log. I jump over the log. So it goes something like that. I also have a vertical asymptote right now at y equals 0, or x equals 0. X equals 0. Oh no, I messed it up. Okay, a vertical asymptote of our parent is x equals 0. I apologize. I messed up the last example. Your parent graph, you have a vertical asymptote x equals 0. Make sure you get that and correct it. I apologize sincerely with the deepest regrets. 1,000 apologies. Okay, so if we multiply our x's by 1/2, this point at 1 will now be here. These will all move in closer, so this is going to kind of come up like that and come in about that. Okay, it'll move 1/2 closer to it, so it kind of looks like it is just a little bit less steep. Then I need to reflect it over the x-axis. So when I reflect it over the x-axis, it'll come down, and then it'll get up and closer. The vertical asymptote has... Try that again. The vertical asymptote has not even moved at all yet. Okay, last step, move it down 3. So I move my point here down 1, 2, 3. There is my point. So it's going to come up, get closer to the y-axis and go down and get further out. My vertical asymptote stays at x equals 0. It's only when it moves left or right that that vertical asymptote will actually move. Other instances, you may have to just find the x-intercept of your graph. Don't forget, if you're looking for the x-intercept, that's where you cross the y or the x-axis, so your y value is going to be 0. No matter where you cross the y or the x-axis, your y value is going to be 0. So since I know my y value is going to be 0, I can put that in for f of x, so that I have 2 log 3 times x plus 5. And now if I want to rewrite this, I need to get rid of this 2. It's kind of in the way in order to rewrite this as an exponential. So I can divide both sides by 2. 0 divided by 2 is 0. And I'm left with log base 3 of x plus 5. Now I have kind of a way that I can rewrite this as an exponential. I have 3 raised to the 0. So I will have 3 to the 0 equals the number inside, which is x plus 5. It's the whole thing. I know 3 to the 0 is 1 equals x plus 5. Subtract 4 minus 4, so x is equal to -3. So my x-intercept for this one is going to be -3, 0. Make sure you put in 0 for f of x. Make sure that you get rid of anything that's multiplying, or if you had like +3 or anything like that, you move that over so that it looks similar to this. And then you can rewrite it as an exponential. Last type of problem you may see is something like this, where you have the natural log of something equals natural log of something else, where you may have something like log of 3 of x equals log of 3 of x plus 4 or something. The only thing you really have to make sure is that the bases are the same in your log. Since in this case I know I have natural logs, my base is going to be e no matter what. So I have the same base. So this is similar to the exponential. Since I have natural log of something equals natural log of something else, so then that something must equal that something else in order for this to be true. So then 3x minus 2 equals 4, and just solve for x. So plus 2. So plus 2 to both sides. So 3x equals 6. So divide by the divide by 3 on both sides, so x equals 2. There is your answer. X has equaled 2. Yeah, I said it twice. Okay, make sure that you guys are ready for 3-1-3-2 quiz. No calculator for all of it. You're going to have to solve, you're going to have to graph, you're going to have to do all that fun stuff. Rewrite as exponential, rewrite as logarithm. Be ready. You guys are great, awesome, love you, pound it. Yeah, digital pound it. Woohoo!